Welcome! How a three-stage methodology saves production costs, short time and sustainably. By myself, Dr. Jorg Demmel. Contents. First, introduction. Second, the three-stage methodology, the golden cycle, in the three steps. First, accepted process environment. Second, effective quality tools. And third, essential technical support. Results all in fourth, high performance increase. And third, the summary. First, introduction. Some background about myself, about me, Dr. Jorg Demmel. I've created 25 years of experience on highest level. I worked for the Fraunhofer Society, the biggest applied research institution in Europe, and I worked in different leading positions for Volkswagen, world car manufacturer #1. I led a lot of projects, around 50 for about 30 companies in product and process development and manufacturing re-engineering. I'm a mechanical engineer, I'm a PhD in applied materials, and I have a business management degree. First, introduction. Some background about myself, about me, Dr. Jorg Demmel. I've created 25 years of experience on highest level. I worked for the Fraunhofer Society, the biggest applied research institute. Second, the golden cycle. It starts first with an accepted process environment. It goes on with second, the usage of effective quality tools. And third, essential technical support.
And all results in high. Second, the golden.
Let's compare the golden cycle as an industry-approved approach with the establishment with Kaizen's PDCA and Six Sigma's technic-cycle. Left the PDCA and on the right the technic-cycle, centered the golden cycle. While Kaizen's approach is a continuous improvement approach, the golden cycle and technic are focusing on process improvements. While the target of PDCA is reducing waste, reducing MUDA, the 7 kinds of waste like inventory or motion or waiting times, the target of technic is high process capability, Six Sigma process capability, and the golden cycle's target is reducing or eliminating the priorized failures. While PDCA and golden cycle are easy to learn, technic's approach is really hard to learn. There are a lot of specialists' knowledge necessary, black, green, or yellow belts, for example. Quality tools, statistics like hepatitis testing are used in Six Sigma. And the golden cycle uses the 7 quality basic tools like Pareto, like other sheets or easy tools, for example, like a histogram or a quality control card or Ishikawa as well. And in addition, the golden cycle includes expert advice, and this really accelerates the problem solving process. Now let's go deeper in the golden cycle. The first step is an accepted process environment. It's important to set up a process where the employees, where the team members feel good, and they have all necessary requirements to solve the problems, and all the resources and the space and the time what they need. I would say there are 5 top recommendations. First, a commitment between the involved parties, between management and the team lead and the team and all the other involved parties is essential. Second, a place, a shop floor working and meeting place is really important, and it should be not just in the corner. Nobody mention it. It should be just in between, in the center of your manufacturing line, like your shop floor place for manufacturing for quantity as well. Third, it's important at targeted visualization and reporting that on one view in the first seconds everybody can see if there is a problem, what is the problem, how is it going, is there immediate measure or a series measure. That's really one essential element of success. Fourth, we recommend using as a working process the Kaizen's PDCA-cycle, plan, do, check, act. And fifth, it's important that there is an accepted project lead, and I used couple principle, and I will introduce this and other elements in the next minutes. Let's compare a standard manufacturing or production shop floor organization. You see it on the left. On the right, you see just scrap in a container. And I have seen over the last 25 years many companies, many production and assembly lines. Many of them use shop floor management on daily basis. Main focus are delivery obligations and production costs. But almost no company was making the same great efforts to solve the permanent quality problems. And that's something I think we all should think about. On the next chart, let's take a look on the reporting, how we visualize our problem-solving process. We have some organizational issues. The goal has to be visualized. It's important to find the right location for this golden cycle meeting and working place in the coast center. The responsible team has to be mentioned on this board. The meeting times, everybody knows 5S, the rules, the legend for the board, and maybe some others. Then we start with the top level. There is a matrix tool I will introduce later. Then we go in our own coast center. On level 1 we have a target actual chart, for example for the top 5 failures. There you see on one view the performance over the last weeks of the top failures. On the second level we recommend a Pareto diagram, specific and approved. There we have the weight of each failure, the status. There you see some colors, red, yellow and green, and the responsibility and the date. On level 3, for the top failures, one pages are recommended for each failure, one pager. There are some specifics, and I will go deeper on the next charts. Then level 4 shows for every failure the target actual chart with the measure and the measure effectiveness. That's very important to visualize the effectiveness of your measure. Level 5 are additional tools like Ishikawa, like correlations, or other analytics or products are important as well. Good parts compared to the failure parts. Now I like to give you an idea of the couple principle about the project lead. The effective daily quality work should follow the PDCA-cycle, and therein from myself so-called couple principle has proven its worth. The controller is responsible for the tasks in the phases plan and check, and the converter for the more operational tasks in the do and act phases. I like to conclude step 1, the accepted process environment, with a reference. At Volkswagen's plant in Brunswick, Lower Saxony in Germany, there was a competition between all plants, about 60 plants worldwide, of the component, and there a team of myself worked on reducing waste, and we worked really hard with this golden cycle methodology, and after 6 months we reached a reduction of 47% of waste. That means it really works, and my recommendation is raise quality on the same organizational level as quantity. Now let's dive in step 2, effective quality tools. The chart shows standardized and customized tool set on the left and standard reports on the right. The question is, why not using effective and efficient quality tools instead of complex standard reports? I recommend using tools like an easy quality matrix, where you see in detail in which steps the problems are, target actual charts, Pareto charts, fishbone diagrams, and one-pages. Just really easy charts everybody understands. And I will go deeper in the next charts. Let's introduce the so-called quality matrix. You see the failures in the lines. What happens? And where they occur in the process steps in the columns. There you see on one view which failure in which step is worst. Worst is in this case number 9 points, the red field. Yellow is 3 points. It's medium. It's not good as well. Then other failures have just 1 point, and if there is no problem, there is just nothing in this field. And you can really visualize these two information for the failures. There you have the failure Pareto on the right side, and for the processes, which processes are the most difficult process steps. This diagram you see on the bottom. Now let's look on the Pareto diagram. It's a specific and approved diagram by my own experience over many years. Here you see the failure increase in cylinder week number 5. Top 1 there are in total 9 failures, and there was an increase of 1 in this week. Top 2 there are 6, increase of 1, and top 3 4, for example. Then you see the status. The status is green, yellow, and red. Green, that's very important, is the failure only if there's a measure effectiveness greater than 95%. Yellow is all between 50% and 95%, and every failure below 50% measure effectiveness is red. The responsibility is important. Here we follow the PPP, the polluter pays principle. Here you find the department, but it's better to put the personal name in this column. And on the right you see the fixed date where the next main step has to be delivered. That's all, and that has to be tracked week by week. Now let's take a look on the one-pager. It's a central element where you and the team documents the failure analysis, the failure occurrence, and the measures in one document on one page. We call it as well the 8D or 8-dimension report. It has 8 dimensions, and here I show you a specific and approved version for shop floor. Let's get through. First, it's important to establish a responsible team or a person and the date of posting. You see the date on top left and the responsible person on bottom right. Second, the failure description. The pictures are a part. Okay, I don't show you the part, but the part is very important to put it on the table, a good and bad part. But here you see the picture of the heat treatment and active feeding of the gear wheel, as well as the microsection of the crackles. Very important and specific is the traffic light symbol. Here you see a green symbol because this failure is solved 100% with 100% measure effectiveness. You have yellow and red colors as well, depends on the measure effectiveness. The third element is to implement immediate actions, very important for isolation of the problem. Fourth, define all root causes. Work with hypothesis. It's very important to work with hypothesis and to go deep in the failure analysis, not working with some symptoms. The fifth point is to plan, test, and implement series measures with responsibilities and dates. Very important. Six, that's a specific experience I made, is performance tracking. Really ask for performance and don't believe if the performance looks very pretty and the problem still occurs. There's something wrong then. Seventh, failure prevention is very important. You see here on the bottom and lessons learned using process FMEA is very good tool to document the lessons learned and to avoid recurring the failure in future. And 8, last but not least, the completion and the closing of the report. Congratulate the main contributors or the team. Yes, that's it. Now let's take a look on analysis tool. I recommend it's very important for each problem to make a course analysis, to find the real problems, or I would say in Six Sigma speech, the X that causes the Y is the problem. There I recommend the fishbone or so-called Ishikawa chart. It has 5 or sometimes in this case 6 possible failure bones or arms, machines, methods, the people, the materials, the environment, and measurements. And then you go in the team with experts, go through all possible causes, and you exclude by expert the causes. For example, here machine, there was one root cause, the machine setting, the program was okay, but another influence wasn't. You go on the methods, and here you see as well 2 could be excluded, but one method, here it's the kind of heat treatment, it wasn't okay. It is selected by the team, and then you go through, and at the end you have some possible causes left, and last but not least you have to test them to determine really the key X's to impact Y. And that's it. That's the quality tool with sense of proportion, and that's important to use the tools that best fit for you, and to really get the causes and to eliminate the causes. Now we go on with the third step, essential technical support, and I would like to explain it by an example. We will go on 4 slides a little in detail, but it's important to understand the method. The example is gear wheel, which is cross-cutted, turned, broached. The teeth are broached and inductive hardened. After that grinding process and testing of hardness, geometry goes on. The problem, you see it here on the right, are cracks starting from the surface, vertical, going deep about 0.3 or 4 millimeters. They were found after testing, after hardening. They were sporadic, and some shifts more and others less. We get through the before mentioned Ishikawa or fishbone diagram. The measurement, that's something you test first, was okay. There wasn't any failure. It was analyzed and was really in a good condition. The material, the raw materials we tested, there were 2 suppliers. It took 2 or 3 weeks to get all details, but they were really okay as well, not the cause for this problem. The machine were some were okay. Cross-cutting has no influence on the crackles because in another area, turning as well, no influence. Grinding is after the failure occurs and was caused, no influence as well. But broaching and hardening has still an influence, therefore a red X. The methods have an influence as well. How you broach, how you harden your gear wheel, and the people as well, because as mentioned there was some shift influence. That's the environment as well, because it's very important to have a clean cooling and fluid and other processes have to be clean, for example. Then I got a technical advice, a statement about hardening crackles by myself, and I also asked a third-party expert. Internal stress in the teeth can lead to cracks during and after cooling and heat treatment process. Internal stress consists mainly of heat and internal transformation stresses. Heat stress is a result of uneven temperature distribution over cross-section during cooling. That means we have to look on the hardening process there, especially on the cooling process. And so we go on next slide. Now we look in detail on the hardening process, how an uneven temperature distribution over cross-section during cooling could happen. We took a look on the so-called TTT or transformation time temperature diagram, and there I found for this specific material that the percentage of polymer additive in the cooling media was somewhat too low. If it's too low, then the cooling is too strong and it could cause stress and crackles in the material. Then we made a first test with a low polymer concentration. The result is we really achieved what we were looking for. We caused fine cracks, but the concentration was really not as low as we made the test. That means there must be at least a second course. The series measures we started now that was first increase of polymer concentration. The parts were tested on hardness, microstructure, etc. And we established a control card with a lower and upper control limit for these polymer concentration. You see it below. And the series measure effectiveness. I talked about this before. It's very important to measure it and to always implement only one measure. The failures were really on a lower level. The measure effectiveness was about 80%. That means yellow traffic sign, but there were still some crackles. Now we look on the last 20% on the process before inductive hardening, the broaching process of the teeth. The question is there a geometry variance which increases the uneven temperature distribution? Looking now in detail on the broaching process, we found differences regarding to tool life of the broaching tools. Result was the tooth surface roughness increases at some point with the number of broaching hubs. So we made a second test with some gear wheels with increased roughness and burr on the surface, on the teeth. The result was very little number of cracks after hardening. So we got the second influence. The third test, parts with same burr on the teeth and the low polymer as before in the first test, the slide before. The result was that we really produced fine cracks on a significant higher level. Now we got it quad erat demonstrandum, I can say. The second series measures we implemented were the tool recutting process has to be improved and standardized. Then testing with this improved tools, measuring the tooth surfaces, everything was well, and we implemented another control card for these tool recutting process, or better to say, the number of broaching hubs. The series measures in total with the polymer concentration increase, the inductive hardening process was now great 100%. Failures doesn't occur anymore, and that's what I would like to show you on the next page. On this page, in the last page of this gear wheel example, you see the performance of the failure. We had to see it on the left before the introduction of 100% series countermeasures. The red columns there you see in total percentages up to 6.5% parts with micro crackles. and there's a change between 0 and 6.5%. In total, we had 745 NOK parts of 150,000 produced parts, and it was really not okay for this parts. It was not tolerable. After series measures, you see it here at about the 80th day, after 2.5 months after starting our analysis and finding the multidimensional causes, we solved really the problem sustainably. There was no failure for the next about 250,000 parts. You see there was 0 NOK part, and we tested every part 100%. And still about 1 year after this measures, and still now there isn't any failure. That means we have really a sustainably measure. We understand the causes, and we really control the process now with a really high capability. And the resume is, asking an expert is not a weakness, but a strength, because so we could really solve this problem. Now let's take, last but not least, a look on the results. Force performance increase. We expect solving your never solved problem and further effects if you have implemented the golden cycle, like reduced rejects and rework, less SOX and capital tie-up, increased output, higher motivated employees, a rise in customer satisfaction, and increased profits.
Third, summary. We talked about the 3 stages of the golden cycle. First, accepted process environment. Second, effective quality tools. And third, essential technical support. All results in solving your never solved manufacturing problems. The 3 core theses are: first, rise quality on the same level as quantity. Second, use quality tools with a sense of proportion that best fit for you. And third, summary. We talked about the 3 stages of the golden cycle. First, thank you for your audience. You can see on this last slide where you find us.